In this question, it is given that a cylindrical metallic rod in thermal contact with two reservoirs of heat at its two ends conducts an amount of heat in Q in time t. The metallic rod is melted and the material is formed into a rod of half the radius of original rod. What is the amount of heat conducted by the new rod when placed in thermal contact with the two reservoirs in time t? So basically, in this question, what they're trying to say that a cylindrical rod which is in contact with two reservoirs. So over here we are considering a rod over here, and take it as its radius was r and its length was l. Now the two ends conduct an amount of energy q in time t. The metallic rod is melted. That means we are taking the same material, same density, that means same volume, and it is formed into a rod of half the radius of original rod. Now we reduce the radius, so definitely the length is going to increase. So now the radius becomes equal to, take it as r divided by 2. So definitely this length is going to increase. Let's say now the length is L dash. So while equating the initial volume and final volume, we can find out what about the value of length of this conductor right now. So what we'll do is, or you can write in terms of volume as constant also, because we know that this dq divided by dt is equal to nothing but k into a into delta t divided by the value of L. In this situation, volume is constant, so we can write the value of volume is equal to area into length. So length is not given, so we can write the value of L is equal to volume divided by area, because we know that volume is going to be constant in this situation. So we can write dq by dt is equal to k into a into delta t divided by, instead of L we can take it as v by a. So this a we can write on the numerator, so the value of dq by dt will be equal to k into a square into delta t divided by volume v. So in this, according to this question, we are keeping each and everything as constant other than radius. So what we can do is we can write as k into this. We know that area of rod is nothing but pi r square. So a square we can take it as nothing but pi square r raised to 4 into delta t divided by volume, we can take it as v. So the value of dq by dt we can write directly proportional to r raised to 4, while taking other things like volume, delta t and k are constant. Now we can identify the relation between them, that is dq divided by dt in the first situation divided by dq by dt in the second situation, which is equal to nothing but r1 divided by r2 raised to 4. So we can write dq by dt in the first situation is represented by q, and dq by dt in the second situation we need to find out. I'm just writing it as q dash is equal to r in the first situation is r, and r in second situation is r by 2 raised to 4. So we can write the value of q divided by q dash is equal to this r and r get cancelled, so we can write 2 raised to 4. So the value of q dash can be written as nothing but q divided by 2 raised to 4 is nothing but 16. So we can write as q divided by 16.